Alright, you are most welcome, ladies and gentlemen. Once again, we want to continue from where we ended. Don't forget, we are still looking at complex numbers. We started with the general form, the introductory part of it. We looked at algebra, but we started with a little bit. We looked at the addition of complex numbers, of which we concluded that if you have any two complex numbers with both having real parts and imaginary parts, we ended by saying that when we talk about addition of those two complex numbers, you end up by saying that the resultant answer will be the summation of the individual parts. We'll have the summation of the individual real parts and also the summation of the individual imaginary parts. Right now, we want to continue as a look at this, and we said that subtraction of complex numbers. We want to see what happens once again. So this is, we shall consider some two complex numbers. For example, this one. With that and z2 to be equal to x2 plus y2i. Remember, every complex number must have the imaginary part, and the real part. Imaginary part and the real part. The imaginary part is the one that has this property I, this one here, and the real part is the one which is independent of the property I. So when we reach ahead and we say that subtraction, that is z1 maybe minus z2, will be equal to x1 plus y1i. This one is minus x2 plus y2i. Those are the two complex numbers. So we end up having this one here is the x1 plus y1i, then minus x2 minus y2i. When you collect like terms together, real parts together and the imaginary parts together, we shall have x1 minus x2, then plus y1 minus y2, then I. So you end up saying that if you have z1 minus z2, you get the answer, but with a real part also and the imaginary part still. The real part is the difference of the two real parts of the two complex numbers, and also the imaginary part, the difference of the two imaginary parts. This is in a case. We can have an example here. An example in this case, and we say that suppose z1 equals 4i and z2 equals 5 plus 2i. So someone is interested in you getting z1 minus what? z2. This one becomes, you get 4i, then minus 5 plus 2 what? 2i. So we are saying that this is 4i minus 5, then minus 2 what? 2i. We said that this negative 5, then plus this one, 4 minus 2, then I. This is what we have been saying. We shall have this one minus this as y1 minus y2. So we have negative 5 plus 2i. This one becomes our final what? Our final answer in this case. This is addition. Someone can go ahead to look at other sides, like maybe we are still continuing with that. This is our number 2. We had number 1. So number 3, we can look at the multiplication. Multiplication of complex numbers. When we talk about multiplication of complex numbers, we shall consider z1 to be equal to x1 plus y1i, then z2 to be equal to x2 plus y2 what? I. When we have this one, we shall have z1 times z2 equals x1 plus y1i, then times x2 plus y2 what? I. So when you have this one, we shall start by saying this one multiply the whole of this x2 plus y2i, then plus this one y1i multiply the whole of x2 plus y2 what? I. That's how this thing goes. Now here we shall open x1 then times x2 plus x1 times y2i plus y1 times x2i. Then lastly we have y1 times y2, then I what? I squared. But you should remember one thing. We say that property I squared is always equal to negative what? Negative 1. So we shall have x1, x2. Now this one will be minus here. So we shall have minus y1, y2 because of this I squared. So when we leave that one, we shall come to this you say that plus x1 y2, then plus this one is x2 y1, then outside we shall put what? When we have this one is the final answer. In this case, there are very many ways of writing this one in that case. So this is the way you just open the brackets and keep on doing what? And keep on multiplying. So we want to continue and we say that we can have an example in that case. So the example can be z1 equals maybe 2 and z2 to be equal to 3 plus 2i. So in this case, we shall have z1 times z2 will be equal to 2 into 3 plus 2i. So this one you open, this is 6 plus this times that is 2, that is 4i. That this one becomes our answer. Another example, we can have example 2, whereby z1 equals 1 minus I and z2 to be equal to maybe 3 plus I. So if you want z1 times z2 will be equal to 1 minus I, then times 3 plus what? I. This one times that is 3, then plus 1 times that is I, negative 1 times 3 minus 3i, and lastly negative I times I, that is I what? Squared. So we have 3, this is this one, this is I minus 3i, that's minus 2i, then this is negative 1 itself, it cancels that one to have positive. So you end up by having 3 plus 1, that is 4 minus 2i. So this one is z1 times z2 as our final answer. What have we obtained from what we started with? We started with the addition, we got the subtraction, we went to multiplication, but we also ended with this. We have not looked at division yet, but what we have seen that when you operate these calculations, when you calculate these numbers, you end up with a complex number. Whether you are adding, the resultant answer will be a complex number with the real part and the imaginary part. Whether you are subtracting, still you get a complex number. Whether you are multiplying two complex numbers, the resultant answer will be a complex number with the real part and imaginary part. For example, someone can ask you that the real part here and the imaginary part here. You can stand up very well and you say that the imaginary part is negative 2 and the real part is what? Is 4. Please, when we are stating the imaginary parts and the real parts, we state it with its sign. If it is negative, we say that negative. If it is positive, we say that positive. Because remember, a complex number we are comparing is general, x plus y. So you take it with the imaginary part, you take it with its what? It's saying. This is in the case of multiplication. We also want to look at the fourth one, which is the what? Division of two complex what? Complex numbers. How do we divide the two complex numbers? We shall have z1 equals x1 plus y1 I, then z2 equals to x2 plus y2 what? I, as usual. And we shall say that this is z1 divided by z2. This one becomes we shall have x1 plus y1 I over x2 plus y2 what? I. This one is x1 plus y1 I, then x2 plus y2 I. In this case, we have x2 minus. How do we divide complex numbers? We make sure that we get something. We have not looked at something called the conjugate, but we shall know its sign. At the moment, let us not confuse ourselves. Let us just say that we come to the denominator. Our aim is to eliminate I from our answer in the denominator here. So you come to the denominator and you change the sign which is here. If it is a plus, sign of the imaginary part. If it is a plus, it becomes minus. If it is a minus, it becomes a what? A plus. So you come and change this sign here from minus to plus or plus to minus. And this is 2i. So you multiply it by up and what? And down. In that case, when we do that one, we are eliminating I from the what? The denominator. And in that case, we say that we are multiplying. This one you get is what we call the conjugate of this one. So the two are conjugates of each other. The conjugate of this one is this, and the conjugate of this one is this. Where so long as we change the sign of the imaginary part, but the real part remains the same. So in this case, when you reach there, we are saying that we open this bracket. This one times that is x1, x2. then x1 times that minus x1 y2i, then plus x2, then y1i, then lastly this one and this one, we have I and I, that is I squared, but this one is already a minus, so that is a plus now. So plus y1, y what? y2. We are saying that this one time that is minus, but minus, we have I squared, which makes it now a plus, because I squared is what? Is minus. So we have this one down here is the difference of two squares, which just come on this one, put a square, and also this one here, y2i, then put a square here. That's it. This one can go back to that. Now this one is correctly the real parts together, x1, x2, then bring this one plus y1, y2. Now when you have this one, put it together, you come to this. This is plus x2, y1, then minus x1, y2. Then this is I over, then this part here, this is x2i squared, this is minus, but there is I squared here, of which if there is I squared here, I squared is already negative 1, to cancel this one plus, but y2i remain is a what? Remain is squared. So we shall have x1, x2 plus y1, y2 over x2 squared plus y2 squared plus x2, y1 minus x1, y2 over x2 squared plus y2 what? Squared. This is I in this case. So when you look at this part and this one, this is real because it doesn't have I. And this is what? Imaginary. It has been as a result of dividing two what? Two complex numbers. Therefore, if you add two complex numbers, also the resultant answer will be what? Will be a complex number with the real part and the imaginary part. That's what we are saying. So any operation should give you that. We want to look at an example and we see somewhere where this one can do what? Can do, and we want to look at what? An example in this case.